Hi, welcome back. In this session, I am going to talk about test for overall model and individual variables. Remember, we are talking about multiple linear regression, so we have more than one explanatory variable. So, we put a null hypothesis as beta 1 equal to beta 2 and so on up to beta k equal to 0 against an alternative hypothesis not all betas are 0. Remember, that means some of those betas can be 0. So, this is our null and alternative hypothesis for F test. So, if we reject the null hypothesis, that means we can actually claim that the overall model is valid, but remember some of those explanatory variables could be statistically insignificant. So, the F statistic is given by mean square regression over mean square error, which is what we get from ANOVA table, or F is also related to R square. So, F is R square over k, where k is the number of explanatory variables in the model over 1 minus R square by n minus k minus 1. So, we can mathematically prove that MSR over MSE is same as R square over k over 1 minus R square over n minus k minus 1. So, now let us look at the ANOVA table for the DAD case. So, here the value of F is greater than 25, which is ratio of MSR over MSE, and the corresponding p value is very low, which is basically almost close to 0. So, now we can conclude that the overall model is statistically significant. So, once we have statistical significance for overall model, we go and test for individual variables. So, for this we use the t test. So, our null hypothesis in this case is beta I equal to 0 against an alternative hypothesis of beta I not equal to 0, and the test statistic t is beta I estimate over standard error of beta I estimate. So, by rejecting the null hypothesis, we can claim that there is a statistically significant relationship between the response variable y and that specific explanatory variable xi. Now, let us look at the coefficient table from SPSS output. This is where we will find the t value and the corresponding p value. So, here I have 4 variables: body weight, HR pulse, body height and RR. So, the first 2 variables are statistically significant at alpha of 0.05, because both those variables have a p value of less than 0.05, which is given in the last column, whereas the last 2 variables, body height and RR, their p value is greater than 0.05. So, one may conclude that they are statistically not significant. Again, we have to be careful because this statistical insignificance may be caused because of things like multicollinearity. So, you have to be careful before we come up with the conclusion that these variables are statistically insignificant.
Sir, the constant has a p value of 0.095. So, should we remove constant from the equation?
Great question. Now, if I go back to this table, you have a p value for constant which is greater than 0.05. Does that mean that I should remove constant? You have to be very careful about the use of alpha, and especially when we are looking at beta naught, the constant. Remember, the regression model itself is trying to establish a relationship between y and explanatory variable. The constant is an optimization constant. So, we are basically using that constant to minimize sum of square errors. So, in most cases, or in almost all cases, we will not remove the constant even if it is statistically insignificant. So, here it is greater than 0.05, that does not mean that we will go and remove the constant from the equation, which is not the right thing to do.